Hi guys, we're starting our chapter on data, a few chapters on data, and this is a video for 8.1. Okay, we start off in our textbook with a chart that's showing us a whole list of cereals and how much sugar there is in, how many grams of sugar there is in a serving of each of these cereals. And on the next page, what we're doing is we're creating something called a dot plot. And a dot plot is a good way of displaying data that's discrete. In other words, it's data that can be counted, and it's not decimals. Okay, it's not continuous data, it's discrete data. So a dot plot would mean that, let me go to the next page here. Nope. Okay, that we look for the lowest value, which is 1, and the highest value, which is 22. And when we create the number line, we're looking to create it such that our lowest and highest number is represented. And in this case, the number line that they give us allows us to count by ones and exactly make it. And then you're putting an X on top of this number that corresponds with the chart. So 4, 11, 7, 10, and so on until you're done. This is what it looks like when you're all done. In fact, I'm going to cut this. Copy. Okay, so what I'm noticing is that a lot of our values are kind of right here. This is where like most of our values are. We do have one value out here, and we would consider that probably an outlier. We have a couple kind of on the low end, but the bulk of our data is right here. And that leads us kind of into the next topic, or the next vocabulary word that we want to talk about, which is distribution. Okay, when we look at our data distribution, when you have symmetric data, okay, that means that if you kind of draw a little hill over the data mostly looks the same. That hill kind of looks the same. Don't look at the data. I mean, obviously it's not perfect. There's 4 x's here, there's not 4 x's here. But generally speaking, we see symmetric hill. Okay, now this next part about skew is opposite of what you think. Okay, so this is skew right, and that's not a misprint. It really does mean skew right. And it feels like it should be left because that's where the high point of the graph is toward the left, but it's actually the direction that's opposite. Okay, so skew right means that you don't have enough data point, you don't have the same amount of data points on the right as you do on the left. Skew left means the low point is on the left hand side. Okay, so it's just a matter of studying that and memorizing it, guys. So if we go back and look at our sugar dot plot, and we draw a line, a little hill over it. Okay, it looks symmetrical right up until we have to draw the hill going all the way out to our outlier, and then we can see that it is skew right. Okay, skew right because there's a low. You know, one way to think of it is, to help you remember, is which side of the hill is bigger. This side of the hill is bigger. Okay. If this is the top, this side is longer. If this is the top, the left-hand side is longer. Okay? It's another way to try to wrap your head around skew left, skew right. Okay, Here's some more in your textbook, some more discussion of symmetric, skew right and skew left. All right. Okay. Box and whisker plots. So some of this is kind of easy, like the minimum data point is the lowest number, all right? The maximum would be the highest number. And you've probably done the median before, okay? The median is when you put all your values in order from least to greatest and you find the one that's in the middle. If there's 2 in the middle, you have to add them up and divide by 2. Things that are new, you probably haven't heard of before, are quartile 1 and quartile 3. What that means is if I know my lowest number and my median, and I do the same strategy to find the median again. I start with the median, I start with the lowest number, and I find the median of that. Okay, so it's basically dividing our data into 4 sections. Now, important to notice, or to know, the 4 sections do not appear to be the same size, okay? However, each section contains 25% of the data. The median divides the data in half. The quartiles divide the data into fourths. So this is 25%, 25%, 25%, 25%. Now, they don't look like they have the same amount of data in them. The whisker on that right hand side between the 3rd quartile and the maximum, that's the longest section. And it'd be tempting to think, wow, there must be a lot of data in there. Nope. What that just means is that there's a wider range of data. The numbers are further apart. There's a bigger difference between them. Okay. One thing that you can tell from a box and whisker plot is you can say, well, half my data is above the median, or 75% of my data is above quartile 1. You cannot, even though your homework will try to trick you and ask you this, they will ask you how many of your data points are exactly this number. And you can't answer that. The box and whiskers plot doesn't tell you that. So you just say cannot be determined. So in your in the past, when you've had data, like if we look back at the sugar grams, if we were going to find the median and the highest number and the lowest number and all that kind of stuff, we would have to physically take these numbers and write them in order from least to greatest. Well, guess what? You do not have to do that anymore. Your calculator will do this for you, which is awesome. So you're going to go to your stat, edit, and I'm going to actually clear my calculator out here because I already have data in here. Second plus 7, 1, 2. Okay, stat, edit. Okay, so I've entered all the data from the sugar chart into my calculator. Now, one thing I will stress over and over again, guys, is double check that you entered in data correctly, because in this particular unit, this particular chapter, the calculator does a lot of the work for you. There's not a lot of work to show. So if you don't enter stuff in right and you have typos, and the typos are the reason you have things wrong, I won't know. I have no way of knowing that. So you won't be able to get partial credit based on the work that you show, because there really isn't a lot of work to show. Okay, so be very cautious. Double check every value you put in. 3, 1. Okay, so once you've done that, then you're going to go to your stat, calc, and one variable statistics. Okay, so that's different. We're not doing any kind of regressions. We're doing one variable statistics because we only filled in L1. Later on, we'll do 2 variable stats, and we're not doing that right now. Just one list. Okay, so this has a lot of cool information in it. All right. X with a line over it tells you the average, which we're not using right now. Sigma X tells you what all the numbers are added together. This, we're going to skip these two, we don't need them. This little circle with a tail is, I think, a lowercase sigma, and that tells you standard deviation, which we don't need yet today. N equaling 20, that's a pretty important thing to look at. It kind of helps you catch typos. So if you know you're supposed to have 20 terms in the list, and you see something other than 20, it might mean you missed one or you doubled up on one. The very bottom of this is what we actually need. Okay, you have to scroll down to get this. Oh, I don't want it on this screen though. I want it on here we go. Nope, one more. Here we go. All right, so these numbers right here are the important 5 numbers that we need in order to make a box and whisker plot. It's your 5-number summary. All right, to help us make a box and whisker plot, it's important to look at our lowest value and our highest value because it helps us decide how to number the box and whisker plot. Here again, we're going to easily be able to count by ones on the chart as they gave it to us. Okay, then to make a box and whisker plot, start with the smallest number and put a vertical line above it. 4.5 is our Q1, so that's here's 4, here's 5, 4.5. Make another little vertical line there. Median, 7. Q3, 10.5. And max is 22. Okay, so you put all those little vertical lines in there. Now to make the box, you connect the 3 in the middle, your Q1, your median, and your Q3. And then you draw whiskers out to your minimum and out to your maximum. Here again, we can see that this data is skew right because from the median, okay, the right-hand side is longer than the left-hand side, so skew right. And if we go back and pull out our picture here, I just want to show you a comparison. Okay. Bring that down to size. Okay, so how can you tell that this is really about the same data? Okay, you can kind of tell because you can see our outlier. Whoa, I didn't mean to do that. You can see the outlier out here is influencing our whisker length. You can see that where we highlighted before that most of our data falls like in this zone, well, that kind of is the same as our box. All right, and we can see that, you know, this couple X's down here pulled this whisker out. Okay, now one thing you can tell from a dot plot, but you can't tell from a box and whisker. If I asked you how many cereals had 10 grams of sugar in it, I can see the 2 X's right here. Okay, but if I was to ask you how many cereals had 10 grams of sugar in it in a box and whisker plot, I have no idea. I have no way of knowing that just from a box and whisker plot. Okay, it could be 2, it could be none, it could be 4. You don't have any way of knowing. Okay, So on your homework, it'll ask you how many, I want to say how many, something about the number 68. How many values were exactly 68? And your answer is cannot be determined, because there's no way of calculating that. Now, I could also ask you about this. What percent had 7 grams or higher? Okay, now, specifically I can ask 7 because 7 is the median. So 7 or higher would be this 25% and this 25%. So that would be 50%. I cannot ask how many were 6 grams or higher, because 6 is not one of our special numbers. It's in the middle of the box. It's nothing special. I could never ask about 6. That would be, again, a question I would say cannot be determined for. All right, lastly, let's talk about histograms. Histograms are a very particular kind of bar graph. Okay, so some important characteristics of them. Number 1, bars touch. Bars are all the same color. And histogram is specifically used for when we sort the data into intervals. Sometimes they're called bins. Okay? So the bars touch, they are all the same color. You can't get creative with this and decide you want to do like a rainbow or something like that. They all have to be the same color. And you sort the data into intervals. Let's talk about the intervals for a second, because there's some important things to know with that. First of all, you have to be consistent, which means you can't have one interval that's 1 to 5 and another interval. Okay, so let me write this down. You cannot have an interval from 1 to 5 and the next one be 6 to 20. Okay? They're not consistent. This only has 1 to 5 in it. This has 615 values in it. You can't do that. Okay? You also cannot do 1 to 5 and then 5 to 10 and then 10 to 15, because then the 5 counts twice and the 10 counts twice. So you can't do that. Okay? Do not do intervals like this. 1, whoops, I'm sorry. I meant to put a 1 there. Okay? Don't do things like 17 to 30, 31 to 44, 45 to 58. Okay, first of all, I'm starting on a super weird number like 17. All right, you should try to be starting on numbers like 1 or something that ends in 0 or 5, depending on how you're counting things. Don't start on like awkward numbers. And this is consistent. It's counting by 13s, but again, that's awkward. Don't do that. Okay? How many intervals should you have? Let me erase this for a second. Okay, consistent. Count by easy numbers. Okay, no overlap. Okay, ideally, you want 5 to 8 intervals, but sometimes you'll see 4 to 10. Okay, 3, you got to spread your data out more. You have to show, better than that. Okay, so 3 is definitely not enough. And 11, unless you have a good reason for it, it's probably not a good idea to have too many. Okay, all right. So the first thing you're making is when you have your raw data is a frequency table. Okay, And this is really easy to do. Okay, 50 goes in this bin, 42 goes here. Now, the authors of this worksheet messed this up. Okay, it was not me, but they don't have all the values on here. We need another bin, 101 to 120. Okay, 45, 68, and so on and so on and so on, till it looks like this. Okay, and then what you can see is I drew bars to represent how many values were in each bin. So this first bar goes up to 4. The very next bar touches it. It looks like one big rectangle-y glob. Okay, all touching. That's what it should look like. So, and I also had to fix on your worksheet the fact that there was no space for the 101 to 120 interval. I'm not sure how that happened. Okay, so again, setting your intervals is important, and let's practice that on the next thing. Okay, so on the next set of data here, we have this data, and again, now I have to make up my intervals. All right, and I see my lowest is 59 and my highest is 95. Now, important, I'm not going to start my first interval with the lowest number. Okay, not going to do that. I'm not going to end my top interval with 95. Okay, we're going to have intervals that start and end reasonably. Now, I could go 50 to 59 and 60 to 69 and 70 to 79, 80 to 89. Okay, that's a possibility. Okay, now it says out of 100 points, so I'd probably choose, if I continued that pattern of intervals, I wouldn't get to 100. Okay, so even though I don't have any data points at 100, I might choose 51 to 60, 61 to 70, 71 to 80, 81 to 90, 91 to 100. Okay, one thing I'll point out is look at my intervals. They're nice and even, 51, 61, 71, 81, 91. These all end in zeros. So that's important. Okay? All right, and again, you go through that whole same process of putting the numbers into the bins. Now, I am following the guideline of having, you know, about 5 to 9 bins or 5 to 8 bins, but no more than 10, no less than 4. Okay? Since this is test scores, you know, it depends on the situation. I mean, technically, somebody could have gotten a 0. And you could justify to me, well, because it's possible to get a 0, I would make bins such that I could account for that. Maybe you could make bins of 1 to 20, 21 to 40, 41 to 60. I will admit that sometimes I make my bins like this. It's easier. Okay. The issue will just be that these will be empty bins, and I'm not sure if having those empty bins is really worth, you know, 2 empty bins is actually worth it. So I wouldn't choose it that way, but it wouldn't be wrong. Okay, in your textbook, we're still in 8.1, and it's problem 3. This is where the textbook gets into histograms. And I want to point out a few things. First of all, again, they show the word bin here. Frequency is how often a data point goes into a bin. It's basically how many tally marks you had in that bin. Histograms are good for continuous data. You can use them for discrete data also, but they're good for continuous data as well. Okay, for example, if you're talking about data, you can't do a dot plot for data that has a decimal to it, because those x's, you know, where are you going to put an x if it's 1.2? And then you start getting it starts getting too complicated when the x's could be literally anywhere along this line. So, you know, a dot plot is good for discrete data. Box and whisker plots could go either way. And histograms can go either way. Discrete or continuous data. Alright, so one thing I want to talk about is, nope, I didn't want that. Turn that off. Alright, discrete intervals. So on a previous page here, I'm going to take this off. Discrete intervals look like this. You know, they're that, you know, they have the dash in between them. Sorry, I can't talk and compute at the same time here, so I'm sorry for all the pauses. But we've got 1-20, 21-40, 41-60. So the dash system of writing an interval is great for discrete data. However, if we have a decimal like 20.4, if we have a decimal like 20.4, okay, we cannot put a hash mark for 20.4 in that bin. We can't put one there. And we also can't put it there because it's in between 20 and 21. So the whole dash system is only good for discrete data. As soon as you can have decimals, it doesn't work anymore. So then we have another way of writing intervals, which is with complex or compound inequalities. Okay, so let me blow this up even more. Okay, so here's how to interpret this situation. Okay, you have, and I'm going to write them to the side too. All right, you have this first bin represents 0 less than or equal to x less than 5. Okay, so the next bin starts with 5 again, but see, this one has an equal bar now. This one does not have an equal bar, which means that if I had a value of 4.9, it would go in the first bin. Okay, if I had a value of 5, it would go in the second bin because that's where the equal bar is. It can be equal to 5 here. It cannot be equal to 5 in the first bin. Then the next bin is 10 less than or equal to x less than 15, and so on. So that's the bins that are represented here. And that can get kind of awkward to write under each thing. Okay, you can see how I squished it in. Alright, so this is a little longer to write than the dash method, so that's why it's, you know, 0, 5, 10, 15, 20. Each number represents the start of the bin. So this bin represents all the numbers that are 5 and higher until I get to 10. Okay, 10 and higher goes in the next bin. 15 and higher goes in the bin after that, and 20 and higher goes in the bin after that. Okay? Have a good night and see you next time.